I'm Jeff Garland. This is the C++26 preview. So let me ask a couple of questions first. Who all in the room, spends their life devoted to the mailing list, the WG21 mailing list, looking over every proposal? All right, we got 2. Okay, perfect. And they're young guys too, that's important. Yeah, if you don't do that, it's easy to get lost in the avalanche of things that are going on. So what I'm hoping to do today is just give you a little bit of insight into that. Does anybody know that there's a way to get rid of the...
And then, yeah.
There we go. Perfect. Okay.
I don't think that was what I said, but it worked.
Yeah, that's what you said. All right. So we're going to take a tour on what's already in process for C++26. So as far as the status of C++26, even though if you haven't noticed, ISO hasn't actually shipped 23 yet technically, but the committee has been done with 23 for a very long time now. And the fact of the matter is that 26 is going to ship in 26 as far as the committee is concerned. It's just part of how we work now. And so that is not going to change. And all of the proposals you're going to see today are either going to be on that train or they're not going to be on that train. I'm mostly focused today on stuff that's pretty much already on the train. Because it's either in the working draft for C++26 already, or it's getting pretty close to that. Not everything fits in that category, and I'll be explicit about when that is. So the committee is doing much of its work virtually these days. Even the 3 face-to-face meetings every year are actually virtual meetings. So by the way, if you are interested in the standardization process and you want to be part of it, please see me. If you don't have a company, for example, you're not working for a Google or somebody like that already can put you on the standards committee. The Boost Foundation sponsors alternate representatives to the standardization committee. So if you've got a paper or something that you're going to write, you can do that now without having to go travel around the world to meetings. So that's really one of the great things that did come out of the pandemic, is it opened the door to people who can't really afford to travel, do all that stuff. They maybe have a proposal and so forth. So that's part of the Boost Foundation outreach. So much of it's going on virtually. So what's the schedule look like? Well, the schedule is the same every 3 years. There's basically moved the bar 3 years, and you can see where the end is. So the 2022 O2 meeting in Kent, Washington was really the last meeting that we spent on C++23. And so really we've been working since 2022 on C++26. And so the feature freeze, which is the point at which there will be no more design changes, is literally only a few months away now. So that's why what you're going to see today isn't fully baked, obviously, but it's starting to get pretty close. So there's only 3 face-to-face meetings prior to that design freeze. The draft then gets another few months to finish the wording, and so that will ship in 2025, in June of 2025. And then after that, there's a period of about a year where we do bug fixing, national body reviews, all of that kind of stuff. That's, you can consider that, if you're a software developer, that's your, last polishing phase. And then after that, it goes to ISO, and ISO does the final approvals. Okay. So what were the priorities for C++26? Because it's a little too late to be starting with any kind of priorities at this point. Well, bug fixes are always a high priority. There's a number. I don't have a lot to talk about today because I'm going to actually avoid talking about a lot of tiny details, because there's a lot of tiny details. And concurrency support is probably the biggest one. I'm going to just skim over STD execution, as it turns out, because I'm going to have to skim over anything big in this presentation, right? I have an hour and a half. So this is going to be like skipping a rock on a pond, where you're going to see the full breadth of things, but you're not going to see a lot of super depth here. But I am, in this slide deck, I have all the links to all of the details that you can go to follow up on. And of course, you can talk to people in the hallway, myself included, about these proposals, about more details on them. So some of the three big things from a language feature point of view: reflection, contracts, and pattern matching. I'm not going to talk about pattern matching today. Michael Park, who is the primary author behind that, is here. You should talk to him if you want to know more about pattern matching. He mentioned to me earlier this week that he's not optimistic that pattern matching will make it in C++26, just because there's so many other priorities for the committee. And so that one I'm not going to really talk about today. I'll talk about reflections and contracts. Those, in theory, are on track. They're still working their way through the committee. They're not, sort of in the working paper. There's additional features to ranges and also format. We're going to go through a lot of those. A lot of those are already done. They're basically already done. Not ranges, though. I will say the ranges stuff is a little bit late. Some of the stuff for ranges really should have been earlier. So in general, this is the way it works, right? Like there's this overlapping set of periods, between various releases. So how many people know about CPP reference? Everybody, I'm sure, yeah. So if you're not aware, CPP reference has this great, page, and this page tells you the status of all of the things that are going in a given release of C++. So this is like the easiest way to sort of keep up with things if you're really interested in following standardization. But more importantly, it tells you whether or not it's been implemented in any of the major compilers at this point. And so what tends to happen is when a language feature or a library feature goes in to the working paper of the standard, which means it's not fully approved yet, because at any moment it could be ripped out. That has happened, right? That happened to contracts. It happened to concepts. Just being written in the paper is not the final thing. You have to get to the final vote for the standard before you can be 100% sure it's going in. But the reality is, I think that's largely the exception rather than the rule, especially with smaller proposals. They basically, once they're in the working paper, that's the end of the discussion and they're done. So you can see there's quite a lot of language features here already. I'm going to talk about some of those. And there's actually quite a long list of library features as well. And you'll see these links here. These are the P number papers. Those are the papers that describe the feature, that motivate the feature, and describe the wording and all of the details about what it takes to put them in the standard. So this is a great resource. I use this constantly. And now I have to go back. There we go. And now
Move the mouse away, down.
Is that what you do? Just move the mouse away? Thank you. All right, but it reset where I was. Okay. So here's the general outline of the talk. I'm going to go through the language features first, and then we'll go through the library features. These are split up into sections based on general topics. Within each one of these sections, there are actually many things. So you've got to keep me on time because we've got a lot to go through. Okay, so let's deal with some sort of basic language features first. So one of the simplest features is just adding some characters into the character set. So if you didn't know, you can't use $, for example, right now in the name of a variable. But C23 has been adding these, and C++ is going to add these too. This is already in the draft. Several compilers had already supported this as an extension. So this is the kind of thing that is very simple, but it takes a little bit of work to do. Here's one that might actually be a little bit more relevant to day-to-day programmers, and that is being able to generate your own message in a static assert. So in this case, what we're basically doing here on line 2 is we're creating a constant expression. That constant expression using STD format is then going to come out when the static assert fails, which is something you cannot do today. Maybe this is going to go faster than I thought. So another thing that's part of C++26 at the moment is this nice placeholder, which is basically the underscore. So if you're looking on the right-hand side here, this is the after. So I think the thought here on the lock guard is it's not really important what the name of this variable is because you don't actually use it for anything. You just create it, and then of course it destructs at the end of the scope and releases the lock. That's really the primary use of the lock guard. And so you can't really sort of make the mistake. Structured bindings is another good example where you just want to ignore one of the returns from something that returns, a structure that you're destructuring into several variables. Okay, and this is, I think, you can do this kind of stuff like, Perl and all these other languages. Yes, please.
Can I use multiple of them in the same string?
Yes, you can use multiple of them.
So it breaks existing code if you happen to be referring to one of those. But
No, I think if you have only one, it still works. Like the old one, you can refer to it. But if you have multiple ones, you can't refer to it. So it's I think, backwards compatible.
oh,
Yeah, because you can't do that now. Yeah, Ben.
I might be foreshadowing a feature in like structured bindings introducing a pack. I don't know if we're getting that in 26, but if we are, does this work? Can you name the pack with underscore?
That's a really good interaction question that I don't know the answer to. Yeah. But you'll actually see this in a lot of other 26 proposals where they use this because it's something you want to do on a fairly frequent basis. So Jody is not in the room here, but actually from this conference last year or the year before, I guess last year it was, is this Variadic Friends capability. And so the first section of this code here, lines 1 through 7, this is the poor man's attempt at what you'd like to be able to do, which is at the bottom here. And the only reason you can't do the bottom there is the word friend. And basically you want to have a list of types that you want to make friends and in a Variadic template. And so you could look at this as a minor bug fix, to the standard, but it took a decent amount of work to actually make it happen. You have to write the paper, you have to motivate it and explain it. He has, in this paper, there's a number of use cases, that he motivates this particular feature. And if you see him and you're interested in why this would be a useful thing to do, you can ask him all about all the details, because he is here. Okay, here's another interesting one. Delete should have a reason, right? So basically, the idea here is I can say delete to this on line 2 to old API. So that was the old function name. And I can give this a reason so that when somebody tries to use that function, this error message will come out. So again, these are nice little things, right? Like they're simple things that make the environment better. Yes, Braden.
Is this similar to the static assert messages where it can be a non-string literal, or must these be string literal?
I think you could put a format in here as long as it's a constant expression. I think that it should be okay. but you can double check me on that one. In the second one down here, it might be a more typical use where you're, deleting, one of the constructors, and you're doing that for a purpose. And if somebody accidentally manages to write code that would invoke that, or does a std move, then you'll get this very nice result. Yeah,
Is
Peter.
that just like comments you're putting in?
Basically, yeah. But you're going to get it out as an error message is the cool thing, right?
Oh, so if you try and use it, it will.
If you try and use it, you get that error message. I mean, haven't we been talking about error messages are lousy forever, right? Like,
I don't know that. You didn't mention it.
Sorry. But yeah, you can go read the blog post that's linked here, and also it has a lot of really good examples and motivation for it. Yeah.
So obviously I'm familiar with like equals delete for like lifecycle functions and stuff like that if you don't want your class to be copyable. Have you always been able to use it on free functions like that? Or?
You have.
Oh, okay.
Yeah, see, and that's another thing, right? Like,
Not always.
not always. Okay, John's correcting. But yeah, I don't know when that got in, but for a while, I think.
It
Yeah.
came in with the life cycle.
Okay.
Okay. Yeah. So yeah. Yeah, as a matter of fact, I didn't know that a while back as well. So there's all these surprising things you learn about C++ when you see a presentation. Okay. Pack indexing.
Yes.
People who use Variadics will be cheering. So if you use Variadic templates, you know how difficult it is to do anything. And then, you try to reference, one subpart of the pack. So basically, this is borrowing exactly what you expect here, which is, you're using your familiar, brace syntax, square bracket syntax to index to a particular value. The example is showing, sort of a pretend example where you're adding the beginning and the end of something, and of a given pack. And I think, so the first plus last, so it adds the 1 and the 10, and you're basically expanding and using the size of in this particular case. So yeah, before you were Boost HANA or some other metaprogramming, I don't know, maybe you could have made it work with index. But yeah, this is a nice little thing for Variadics.
Is it just indexing, or can you create subpacks of subranges of it?
That's a really good question.
Plus 29.
plus 29. That I don't know.
Okay.
Go read the paper. You might be able to. This is C++. We usually like to make it possible to do that kind of stuff. So. Okay, so static storage for braced initialization. So right now, the storage situation for braced initialization is a little bit tricky. And especially with this bottom item here, you'll see this pound embed capability here. You want to actually be a little bit more in control of where the storage for something that's as part of an initializer. So just to be clear, the embed is something that isn't fully in yet. So it's still something that's in work, but I suspect it's going to get across the finish line. But the general idea there is you can just embed a file into your code, and it will treat it as the data from that file essentially. So
would it decode formats, or is it just char star?
It's just char star basically. Yeah.
Will it also work for string?
What's that?
Can I also load some text into a string that way?
Yes, you can. Back here.
So is this actually like a preprocessor pragma? Like, is that what we're doing here, or is this actually C++ syntax for the embed?
Yeah, so the point of this actual slide is not really the embed, but it's a motivation. It's a motivation for the facility that the storage behind the initializer list is clearly made static, so that you know, if you did start using something like embed, you would have a real problem if you didn't do that. So.
I believe this is already in C.
Oh,
Like
the
hash
embed?
embed thing.
I-
It's
it-
because it's from a C proposal that it's been accepted.
It probably
the
is,
latest
yeah.
standard,
I don't
yeah.
know if it got in C23 or not. But yeah, the author of this also works with the C committee, so yeah.
Is the storage static only if all the arguments are literals, or is it still static even if an argument is a runtime variable?
It can't be static if it's a runtime variable, but then it can't be an initializer list either. So this is a for initializer list only.
Why not you can say IJK instead of 1, 2, 3?
If they were constants, then yeah, you'd be okay, right? But if they're not constants, they can't be part of an initializer list if they're not a compile time constant.
They can.
Huh?
They can.
You know, like-
Student initializer, you can assign them to
If
student.
you have like multiple items, like if you're gonna call std max with like 5 items, you put them in a initializer list, right?
Yeah, they can.
Interesting.
It just can't be static, that's true. So it's
Yeah.
not gonna go into the static.
Yeah.
Well, no, it still can be static. Size of is null. Memory can be allocated.
So the thing about
Memory's
this-
allocation is static, not assignments.
The issue is like, I mean, the static memory is probably gonna be constant, right? It's gonna go into read-only section, I believe.
So what exactly does it say? The memory allocation is static or the assignments are static?
Yeah. So I guess the Godbolt link doesn't really clarify, but this is, by the way, this is just GCC 14 allowing you to do it, but you can see basically it's created, you know, static placeholder for each one of those.
No, that's just the
numerics.
text section. That's
If we stick a rand in there.
Yeah. Yeah, we're not going to live code that. Oh, it's going to do that again, isn't it? Nice.
so. Do you know what exactly is static? Only the memory allocation or the assignments?
I believe it's only the memory allocation, but you're going to have to check me on that one. Yeah.
Which
I mean,
also means
it's
that
whatever's in the initializer list, I believe, is going to be the
But
static.
it means that the lifetime is infinite now, because previously the lifetime of this thing was guaranteed until the closing semicolon,
Right.
and then it's dangling.
Right.
So do they now have a guarantee that the lifetime is infinite?
Good question.
If it's static, that's what that means.
You'd think so,
The
But-
compiler could reuse the static
but
memory.
I don't think you can access it any other way, though, right? Like,
No, I could hoard a pointer to it from inside that class.
Static doesn't mean global.
Yeah. I don't know the answer to that.
Static
question.
means infinite lifetime.
Yes, but it doesn't mean global. Doesn't mean you can access it. It just means it's
Sure,
there.
sure, I can. Inside the vector, I can have a pointer to the argument. That's the classic bug with initializer list. You keep a pointer to the first argument, and you don't, and it expires automatically at the end of the semicolon, not at the end of the scope.
I'm not sure it clarifies it easily anyway. Right, so in this case, right, like this example is specifically to avoid putting it on the stack.
That's it, yeah.
And-
Right, that, right where it says the solution, I think, the first line is up.
What's that?
It says we want the semantics of the brace initializer list to match the semantics of string literals.
Right,
String literals have infinite lifetime.
yeah, okay.
They're also like read-only, right? So there is no assignment.
Sure, but forget writing. With the initializer list, you will dangle a pointer. If you retain a pointer past the closing semicolon, you'll dangle a pointer. So this seems to change that.
For some of them, yeah. Not all of them, though. If it has a runtime value in it.
If the memory allocation is static, then maybe not, because memory size of is known at compile time. Only the values aren't.
I mean, like, I don't think you can have, if you have a runtime value in there,
Should you allocate memory statically or initialize it at compile time?
But if you have multiple threads at the same time, you can't have a single block if you have a runtime.
Okay,
Oh, I don't know how it interacts with threads actually.
let's move on. So this one is still a little bit more speculative in that it's still being processed in EWG. That's the Evolution Working Group. But this will allow you to have concepts in template parameters, which is sort of a gap in the template machinery today. And so, you can define a template like this using your concept, my concept, which you could not do before because you cannot pass a concept as a parameter to a template currently. Okay.
But you still can't have variadic packs of those.
Sorry, you can't. No, you probably cannot have variadic packs. No. Yeah. So, and there's a number of other sort of small cleanups that are part of this, but the key here is that it's thank you. It's basically taking care of this gap, which probably should have never been there. So, this is part of a larger initiative. Yeah, Ben.
Can you really not have packs of these? I don't see why not. Is there a reason why not?
I don't think you can have packs of template. That's all.
Yeah.
I don't know how it works with this.
I've never tried it. But
Yeah.
I actually have to be strange. It would have to be like
Sorry, what was that back there?
You can have packs of template parameters.
Okay, so there's a claim in the back of the room that you can have packs of template parameters.
My
So,
memory might be wrong, but I think I've done it.
I think I've done it too. I think it's a thing.
so we got a couple back here that think that's possible. It's amazing what you can do in this language, actually. Sometimes,
Amazing / scary.
yeah, scary in a certain way for sure. But I think again, as part of concepts and using concepts in a first class way, this is a nice fix up for those cases where you couldn't do this kind of thing. And again, it appears like a small thing, but then if you're making a framework that actually really needs to do this capability, you just can't now. So now you will be able to do that in the future. Okay, so let's go a little bit more in depth and let's talk about contracts. Who knows something about contracts in the room? Okay. So P2900 is the quote minimum viable product paper. Because contracts is a big, large facility with a lot of moving parts, the group that's been working on it, I believe it's SG15, is basically tried to produce now what they consider the minimum viable specification that we could, use for having some kind of reasonable contract facility in the language. This proposal was reviewed in Tokyo, and it's making good forward progress. I believe the paper authors here would tell you that they believe they're going to get this into C++26. It may or may not happen. Okay, it certainly is an example of something that was in the working paper and ripped out previously. I think they've been working now basically since, it was 2020 when that happened, or the 2020 release that happened. So we've had now 6 years, 4 years, 5 years, I guess, that they've been working to try and bring this back. So what do we have here? So we have a function f, and in this function, I've got the capability to define a precondition, a postcondition, and a contract assert. Those are the primary things that I can do. And those assertions, like in the second one there, the R is testing the return value and saying, hey, if this is not equal to, or if this is not equal to, then you're violating the postcondition. Okay. Yes. Oh,
Are side effects permitted in this?
Actually, yes, I believe so. And exceptions are actually allowed. That's one way you can fall out. So if there's an exception caused by the precondition, postcondition, or contract evaluation, that will fail the condition. Otherwise, it's a Boolean expression here, basically. Peter.
The contract assert, it's not clear. Is that just at that moment in time, x is not equal to 3, or all throughout the function it can't be 3?
Yeah, I believe it's right at that line only.
So how is it different from normal assert?
The mechanism for error handling is a little different. We'll get to that in a second.
Do these pre-post go into the declaration or definitional?
Declaration.
And
Thank you.
do those affect the type of the function? Are those in the type? If I take a function pointer,
I don't believe they
No.
affect the type.
it's just back to a normal f.
Yeah.
In that case, where are those checked? If I call this function to a function pointer, like I assume since these are in declaration, at least the precondition is checked on the caller side.
Mm-hmm.
But then if I take a function pointer, then is it never checked?
No, I think you're going to get the checking. Hold that thought for just a second, because yeah, we have to talk about the evaluation phase of, how does the evaluation of this actually happen? Yeah.
Is R just like a magic identifier that's known to be the return value, or is something about that syntax introducing that?
That is a really good question, and I think it might be magic, but I'm not 100%
Yeah,
sure.
that's the
to be honest.
syntax for specifying that you want to
Do you want the
talk
return
about the
value?
return value,
Okay.
which I'm calling R.
Yeah, back here.
But it could be anything. It's not R is not magic.
Yeah, R is not magic. The colon is the syntax
colon
to say
is,
the thing before the colon, this is the return value.
Okay.
Okay.
I'm naming it.
All
Does this work for constructors, and where do you put the initializer list?
I don't know about initializer list, but it should work for constructors as well. Any function. By the way, there are a bunch of limits on this minimum viable product, like virtual functions, and this certainly works for things like lambdas, but there are definitely some limits. Virtual functions is the big one that's been called out. Where if you had a base class with a virtual function, do the precondition, post conditions for that base class get checked. So I don't think they have an answer to that yet. So they're going to follow on with the solution for that stuff far in the back here.
What was the motivation for not making it an attribute? Because I know there have been proposals that made it an attribute.
I do not know the history behind why it's not an attribute. It's probably in this paper, which is
There is an
probably
explanation in the paper somewhere.
Yeah,
if
it's
I
probably
remember.
like 100 pages to
Okay.
read. So
It's not 100 pages.
okay, it feels like it's 100 pages to me.
One of the reasons I recall was to avoid misunderstanding of the possible ignoring of syntax within the attributes, if I recall correctly. The attribute syntax suggests that its contents may be ignored if not supported by the implementation. I think they wanted to avoid that.
Okay, so there's basically three different, sets of, evaluation criteria that you can have. So you can have different semantics on the contract evaluation, depending on how you set things up. So the default is to be, enforce, but there's also observe and ignore, which ignore basically says there's going to be no effect of this particular contract violation. So you don't get any evaluation at all.
Do side effects still happen?
That's right. Sorry.
Do side effects still happen?
Do side effects still happen? I don't believe so.
So it actually changes the data.
I think it actually changes what you're doing, because I think the idea behind the ignore is you don't pay the penalty, right? Whereas these others, observe and enforce is going to actually enforce it, and observe is going to allow you to see the contract violation, but it's going to allow the execution to continue.
It's effectively a warning.
Yeah, exactly. And you'll see in a minute, depending on what implementations decide to do here, you may be able to insert logic very deep into the violation handling. So although the way that's written now, it's going to be implementation defined. So basically at runtime, when this evaluates and you get a violation, it's going to call the contract violation handler. Now, if it's in a const eval context, you're actually going to get a compilation error. So if you have a constant expression and the contract is violated as part of that, then you'll get a compile error, which is pretty nice, actually. So this is what the contract violation looks like. You can see it's not really a user accessible thing. This is the machinery that's going to, be under the hood, but it's going to capture a bunch of very interesting information, like the source location, and then the semantic there is that enforce or observe. The ignore is not there because you're not getting any evaluations in the ignore mode, whereas here you're getting information. So, and again, you can't really copy, move, or assign this thing. And so, like I was saying, if they allow you to, override the handle contract violation function, that's that top function, then you would be able to plug into this machinery and do what you want to. So we're going to see what it is with the implementations, whether they actually allow people to do that or not. So, questions? Okay, so this is what about compile time. This example is one of the ones in the paper. So you have a precondition that it's greater than 2 here. So all of these top ones basically, won't compile because, they're in violation in Constexpr context. Okay.
So sorry, when it's in violation, are you able to check that through a constraint or concept? Or is this like a static assert where you just can't check that and it just fails to compile?
Yeah, most of the time, unless, and this is where it gets tricky in C++ because of course we have all this Constexpr const eval evaluation, but at least normally I think about, all these precondition kind of things as runtime checks, right? So your expectation is these are going to be a runtime check. That's exactly how we treat them in the standard. So if you see on a function in the standard, you see a precondition, that's normally we think about that as a runtime check, whereas a mandate is going to be a compile time check, which says, you're just not going to be able to compile. The problem is we have all this Constexpr, business, which makes it complicated what's compile time and what's runtime in the first place. Did I answer the question?
Sort of, yeah.
Sort of. Okay.
I'll try that one.
Okay. All right. That's all I'm going to say about contracts. You're going to have to dig deep on this if you want to go find out all the details, because there's a lot there. Again, it's a topic that needs its own hour and a half of conversation to actually get into. So, okay. Reflection. So this one is one that I'm actually really quite excited about. And I think it's primarily because I believe this is the facility that sort of, puts a SpaceX super heavy booster onto library development, right? Like we've been missing this feature forever. And the fact that, we haven't had the ability to do, reflection kind of stuff, has just meant that everything, is sort of more painful, serialization, whatever. It's probably kept macros alive in many respects because we can't do some code generation capabilities or even, reflect on information so easily. Now, don't get me wrong. I know there's Chris Jusiak and a few other, brilliant metaprogrammers that are able to get around, use source location, hack it into, magic information, but I'll just channel Brett from this morning. The compiler errors are terrible, and the what happens, so hopefully the error handling and the facilities here will make things much better. So this again is meant as a minimum viable product, so don't try to do everything in the world that we want with reflection all in one go. So try to do the minimum set of things that we need to bootstrap that capability, and then add to it as we learn about the facility. So this introduces a number of things. The first thing there is the little hat prefix. That's the reflection operator itself, which takes a an expression and returns this meta info thing, which is an opaque type. So you don't really know what's inside the meta info. We're not going to tell you what's in there. But then you get a whole long laundry list of meta functions, const eval functions that operate on this meta info type. And they can tell you everything about that particular thing. So you get your little hat, and we'll show you an example in a minute, which gives you the meta info, and then you call a function on it. There's also this capability called, reflet, whatever. I don't know how you say it. But these are the ideas. These are allowing you to splice and create grammatical elements from the result of the meta info. So let's look at an example. Let's look at, the classic case of what you wanted to do forever, right? Like you wanted to, get the name of an enum into a string, right? So this is the reflection code that allows you to do that. We've concept constrained it here at the top. So we're only going to allow this on enum types. And so we get the value of the enum type here. And we set the result to unnamed. And that's basically to cover this test case down here. So if I use this color enum and I pass 42, that's an invalid enum for that, or an invalid integer value for that enum. So it doesn't have a name. So then what else are we doing? So we're doing that part here where, we've got the refl, and we have the little hat here, which is going to give us the meta, and this is the meta function here, the enumerators of. So that's giving you the list of the enumerators, which we're then sending into this template lambda, and we're also using this meta function name of here to actually get the string name of it, and that's what will return to result when we find the one that's equal to the one that we're trying to get. Does that make sense? No.
What is that shift operator?
Yeah, that was my question.
That's a really good question, and I hope it's not a slideware problem. Let me just double check, because I think that could be.
Just one question.
No, it is actually doing something. So there's something going on there that I don't know.
Yeah. Will enum to string be part of the standard, or is it just an application now?
This is an application.
Okay, enum to string won't be part of the standard.
No.
No. Okay.
Yeah. Not directly, but you can you can see these libraries will just appear out of the ether, right? Because of course this is not complicated to do. So the cool thing about this one is that there's good compiler support. Thank you. And so you can actually go play with this in experimental mode. This has got to be doing something with the Lambda expansion here, right? So I don't know what it's.
I think it's a replacement for the looping over
the looping.
Yeah,
that makes sense.
The template for is not implemented yet.
Yeah, because I was going to say that Lambda is also not currently invoked, so I'm very confused as to what it does. But I guess it's somehow just, I guess it does it for
It's
each
invoked
somehow.
for every one of the.
Yeah.
I think it's invoked for every one of the ones.
What does expand do in this situation? Takes a parameter pack, converts it into what?
It takes the results of the enumerators out, which is like
That's also a good question.
and it crosses Lambda on each of them.
Oh, no, actually, no, it takes it by
It takes a
ref capture.
So expand calls or shift calls?
Yeah, good question. I don't know.
I'm not sure if it's a placeholder for implementation just to get it to work in the compiler.
I think so, because I think that's what's going on. There's some placeholders here, and yes, if you look at I think if you look in the paper, somebody said it back here. They actually write template 4, okay, which is the enumeration over all. So they don't write it this way. I lifted it from the Godbolt because I didn't want to put something that isn't in 26 yet. into the slide, and it's yet a different feature that I'm not actually going to talk about. So,
Will there be a standardized set of meta functions that we can depend on across implementations?
yes. So we'll get back to that in a second. If I go back through, oops. So that is actually the next slide here is a very, very small snapshot because there are probably, I didn't count them, but there's probably at least 100 of these functions. So I just think that this is like type traits on steroids is the way I'm thinking about this, right? So if you can imagine, you know, any type that you put into this thing, you give it the hat, you get the return, and then you can call all of this kind of stuff. So, and that includes things like being able to, you know, get the members of, you know, a structure or a class, right? So, and you can see here, you know, you're actually able to do some kind of filtering. That I believe is going to use other meta functions as well. So you can basically say, oh, you know, only give me the public functions of this particular class or the public members of this. And in this case, you're expanding the base classes of a particular type. So all of these are, as I said, a very small subset of the things that you can do. And, you know, there's a lot of really interesting information that can be gleaned from these meta functions. Did you have a question? No, you're just, okay. So look at the paper. You'll be impressed with how many of them there are. And like I say, it's really on steroids. But there is another thing we need to talk about. And there's a generative nature to this thing as well, in that there's a facility called define class. And this is where things start to get, you know, I can start to actually now take a structure and I can actually generate it. So I can actually define a class using the reflection capability. And so these two things here, define class and data member spec, are part of the define class. It's not, you know, it's not a full facility, but you can imagine, you know, creating an on-the-fly structure. The paper has a lot of really great examples in it, and it, you know, talks about making variant, making, you know, sorry, what I'm blanking on the other one, but I'll ask the question or go to the question back here.
Yeah, I was just wondering, so it's interesting, so yeah, we have a forward declaration and then I guess it fills out the definition of it afterwards. But so define class, like is the idea here that we have like using namespace std meta somewhere, or is this like
yeah.
Okay,
yeah,
okay.
That's slideware,
Okay,
so you know,
I mean, I was just curious because we also
Yeah.
had like expand in the previous example and we didn't have it.
Expand is something sketchy. It's not in the paper if you go go look for it. So yeah. So that's where there's something about the current implementation that's there.
Can you also add member functions to a class?
I don't believe there's a facility to do that at the moment. So yeah. So that's where it's minimum viable product with more to come later. Yeah.
Do you know if there's any use for the return value from the define class function?
I don't.
Placeholder?
Well, no, I think it actually that's gonna be the type that you've defined, right? You.
It's an auto.
Like a reflection of the type that you just defined.
No, that is the type. That's the name of the type you just defined.
Yeah.
Is it the type sint that we define?
No, you're reflecting on this.
Right. So when you use sint, you'll get this structure generated below.
I'm just wondering what u is.
Sorry, you're wondering what?
What u, the variable u. Wondering what that's used for, if anything.
Yeah, understood.
Doesn't it have to do with meta info?
Actually, I think there's, yeah. Well, good question. Yeah.
Okay, if not member functions, can you define freestanding functions? Basically, how do you do serialization with this?
Yeah, that's a good question, and they don't have an example in the paper. So I suspect you can do it. I'm just not expert enough to tell you how to do it yet.
How does this interact with tools like debuggers?
Good question. And there's some very serious concern, I think, about this. And, again, the error messages, what goes wrong when it doesn't compile. Like what would happen, if this thing was, concept constrained or whatever, what would the error message look like, Brett?
I asked about both.
Yeah.
There wasn't a lot of concern in the SG15 discussion we had about that. I
Okay.
thought there wouldn't be issues, but they seem like those two things seem to be tractable problems. For example, for debugging, it's possible to annotate your emitted binary code with source lines. We just say, where's the declaration for I in this case, and it's line 3, right? So like if you had a crash in the constructor of I, that would trace up through that line. Would that be easy to read? Well, that's a language problem, that's not a tooling problem. Maybe tools like CLion could somehow synthesize what that would look like as if it was reflected out fully. But as to the diagnostics, yeah, that's a quality of implementation issue. You can see some diagnostics if you use the Compile Explorer examples, although from my understanding, both implementations are still beta quality at best or something. So,
Yeah, probably, yeah.
That might be good feedback to give to those authors as to
Yeah.
what they should eventually think about.
So I think that's, go play with it, right? I mean, that's the cool part, is it's on Godbolt, so you can go goof around with it and see what you can do with it. So, Peter, maybe you'll see something in the paper and figure out how to generate methods that I don't know how to generate.
My main concern was actually attributes, and the current decisions did not be too concerned about that yet. Like, how do you add an attribute to I? And I don't know there's a way to express that right now, but maybe that's not a big issue yet.
Because you'd want to be able to say, in your serialization, you might want to have an attribute or something that says, I think you can get the attributes of a if it has an attribute on it, I think you might be able to get the list. So you might be able to, like, if you had a class and you didn't want to serialize all of it, right? And so you're walking through the members, right? So you're getting all the members and you're getting the values of all the members.
I was also thinking of attributes like not null and things like that, so that your diagnostics know more about your code and what it's allowed to do and not allowed to do.
Right.
And like maybe your code warrants, and there is an attribute that maybe you can use. I think we did a mental exercise in walking through the types of reification involved here, and there wasn't a lot of concern about that specifically. Everything else, maybe we have follow-on papers about, well, okay, here's how you do it. Here's how you add an attribute to a reflected, reified data member or something.
I think you said something that I might push back on. Like, how do I step into I? Like, if that's a construction call, like, how am I? Do I literally say, oh, well, now you're stepping into this data member specification?
Well,
fine. So what does my stack look like?
When you stop any debugger, it goes through the instructions in your binary code. And so it would just go to where you jumped, and the jump location would have a location in your source code. It would go down into the constructor code.
No, I've written debuggers.
Okay.
So I understand, but I guess what I'm getting at is I don't, as a developer,
right.
I say step into, and now I'm at that declaration?
No, you'd be
this would have happened at compile time already.
You would be at the
This is no different.
You would be the constructor of that.
Well, let's put it this way. It'd be analogous to what we do right now with macros. So there'd be a similar design questions, and you'd have to have similar kind of facilities available.
Yeah. So I think
if someone starts implementing debuggers and they come up with, oh, this is how it's different than macros, that'd be a very great paper to submit to at least SG15, the Tooling Study Group.
Yeah, and so I'm gonna cut the conversation off because we need to move on.
Yeah.
So far, that's the end of the language section. So, but I do want to talk about the library facilities because there's actually, as I said, there's a small avalanche of things coming down the pike here for the library, and it's easy to overlook what's going on. Now, my personal take on library facilities is that we have a lot of really good work that goes into smoothing over issues in the standard library, and these things can be easily overlooked. And I'm going to talk about a lot of these. We'll probably go through these very fast because we're running a little short on time now. And basically, these are things, there are pain points, right? I mean, why is C++ plus complicated and hard, because it's hard because stuff that you think should just work doesn't, right? Like, and then you're in that compiler thing with all those error messages and so forth. So a whole bunch of these kind of small things are just exactly that. Like, I want to create a string stream from a string view. I can't do it today. It basically just doesn't work because we never put the string view constructor or provided the ability for a string stream to do that. It's a completely valid use case, right? So again, this small cleanup, this is something that's in the draft. I'm sure there's no controversy about it. Sorry, wrong direction. Sorry. Another good example, although this one's still in LAWG, this one actually is personally my own, a use case. The author actually took one of the use cases from me, but this is a thing that's been around for a long, long time. Let's say I've got a string, like a really big, huge string, right? And I want to get a substring of it. Today I have to make a copy of the substring. I can't actually get a subview of a string today, right? So I just want to see, this, thing that I did a find on. I just want to find, a little bit of the string, and I just want to view that temporarily, use it for something, and then move on. So this allows you to get a subview, a string view, basically from the string. Now, of course, there is a danger here, right? Like, because that can dangle, right? Like, if you're not careful, that string view can dangle. But the reality is that there's a lot of cases where you don't want to be moving that data around. You just want to be referencing that data.
Jeff, what stops you from creating a string view from fifth character and all the way to the end today? I mean, you can create string view from an address and length.
You would have to go through the string view constructor and do awkward things with either after constructing the string view or passing in indices to the subview that you want. So this is just a more direct.
String view takes a char star and length.
Right.
So
yeah, but you're going to have to. Yeah, there might be a way to do it, but this is clean. It's clear what's going on, right? And again, it's a little thing that's weird. What?
Are they? Do you have string view already has a subster that returns the string.
Yeah, this is on string, not.
But sub is a string view here, right?
Subview is a string view.
Right, so but you have a sub.subview on the fourth line. That is operating on a string view.
Yeah.
It's the string that doesn't have it today.
Right, but it's also adding to string view, right? Like
line number 4.
Line number 4 also uses it on subview. So do we have two functions that does the same thing on string view now?
Well, we have one on string and one on string view, yeah. So.
We have two on string view.
Because line number.
Subster also returns a string view.
Yes. Okay. That's right.
So subster and subview on string view do exact same thing?
I think so, yeah. Mm-hmm. All right, let's move on. We got to move faster. We're never going to get through this. Okay. So, and again, that one is not done. So if you have concerns about it, raise them now. Operator plus between string and string view. Again, this is a thing you can't do today. And this was an intentional part of the original design of string view. There were concerns. There were future plans. Those future plans have never been realized. And so now it's just time to fix this little thing. I just want to add the string and the string view together, and that's the end of the story. Simple stuff. Bitset. Here's another one. Bitsets are fundamentally constructed from strings, but not from string views, right? Why is that? It's, again, just an omission in the library, and so this is another small cleanup. This one is a little bit different. I don't know if people have used from chars and to chars. Do people use those facilities? Anybody? Yeah? Okay, I got a couple. Any thoughts about the facility itself? We've got the upper, yeah. Why? Because it's fast? Yeah, because it's fast. What do you think about the API? Yeah, the API sucks. Let's face it. I recommend to everybody wrap it up, because unless you want to write, low-level C code, basically that's what you're doing. So unfortunately, the entire space of string numeric conversion in C++ is really a mess. We've managed to mess it up in a big way. I'll say that on a public stage. It's going to be recorded and out on the internet now. But this 2chars result is what you get back. And currently, you basically get this error code thing, right? This line 5 is the new thing that's being added here. And that's because currently, this is what you have to do to tell whether or not there was an error, which is really ugly, right? So what you really just wanted to be able to write was this thing in the bottom in line 13. Give me the result back. If result, use the pointer. Do something with it, right? So it makes it very much like an optional. So that's what this particular facility does. It's not a perfect solution for the interface, but it's better than it was. Here's another example. So basically, the toString facility does something completely different, right? So if you're using IO streams with locales and you're streaming numbers into a string, for example, you get a completely different result than you get with toString. And that's because of the way toString is specified. So we're actually, interestingly enough, we're going to just break all of this because it's so broken already that nobody could possibly be using it properly. And so what we're going to do is we're going to put std format underneath toString. And so then you'll get at least consistent results. And this is particular to floating point and also even integer numerics. But you can see as soon as you put a locale and all of that kind of thing into it, you get weird results that are inconsistent between the two of them. And you don't have a lot of choices with toString, right? So really the way to do this now is really format, but toString is there and it's badly broken before this point in time. Okay, that's strings. That was a few little nice things, right, that are gonna hopefully make it a little nicer. Let's talk about format, because format's about strings too, a lot. So type checking of format arguments. The type checking, I don't know, how many people actually use format or FMT in this room? About 40, 50%, right. Okay, so the particular problem that's here, which is the bottom of this slide, the very last line of the slide, for some reason, it turns out in the standard, that's a runtime error and not a compile time error. All the rest of these are compile time errors, which is great, right? Because when I type the code wrong, I get a compile error and I don't have breakage at runtime. But this bottom one slipped through the cracks. And so it becomes a runtime error, which is undesirable. It's not a runtime error in FMT. So basically what this particular thing says is, TLDR, there's a lot of weird wording in here to just say, make this a compile time error, just like it should have been all along. Okay. So here's part 2. So when we put compile time checking on format strings, then we sort of didn't really give you an easy way to actually have a runtime format string if you needed that, right? So basically all we left you with is this V format thing. And as it turns out, with the V format, it's easy to dangle arguments and make mistakes, okay? So it's another sharp-edged API. And all you wanted to say was, this is a runtime format string, right? So I don't know what it is at compile time, and I just want to make it a runtime format string. So that's what this new facility does here, is it just gives you a first-class way of saying that without any of the issues and having to break down and call make format args, which is very awkward, right? Now, you still will get a runtime error here, obviously, if there's a mismatch between the argument list and the runtime format string. So that part of it is still there. But the number of runtime format strings, how many people use a lot of runtime format strings? Okay, we got one. Yeah. Yeah, it's. I think in the paper they said that it's like less than 5% are ever runtime format strings. It's a very small amount. But if you're going to have to do that, or you need a reason to do it, this is a much better way. Okay. More pain points, right? If you tried to format a pointer in C++23 with format, it wouldn't work. This allows you to do it. You can make it in uppercase or lowercase hex. File system path. There's another one. It seems like a simple thing, right? But nope, because we got Unicode, we got all sort of nasty issues with file system path. But this one's already, it's in the draft and it should be there. And all of the details about really supporting Unicode well were worked out. I've given an example here. This is from the paper as well, of course, is that there's this debug version, which, by the way, you should know about that question mark debug thing. That's actually a handy thing in other contexts as well as part of the format library. But the bottom line here is that, again, edges in the standard library that should have been fixed a while ago. Here's another one. Before you always had to say quote, and actually there's a bug on the slide that should say C++23 on the first line. You had to say quote. You couldn't say print line. I just want to print a blank line, for goodness sake, right? So basically, quote or no quote, it'll work the same in C++26. Okay, that's all a format. Now, just reflecting on the trajectory of format, right? Format was a C++20 feature. And I think you could agree when you look at what's happened in 23 and now 26, it was an unfinished feature in C++20. And I think in 26, we're getting close to, sort of full capability with format. But, we'll see. But I just say that that's a very interesting use case where we incrementally added in, newer facilities in, several standards. It's a very nice way to do it, actually. And so I'm pretty much in favor of that, what they're doing with reflection as well. Minimum viable product. Here's a base capability. Go wild with it. Find out what you can. Here's the things we need to add to it. It cuts down on the amount of time it takes to get things actually there and going. All right, some other things in the general math category. Saturation arithmetic. I got some cheering over here on the sideline. So addition, subtraction, multiplication. These are things that are basic facilities, right? And so saturation arithmetic, there's a slide here. You can go find out about the theory, but basically it just means you won't have an overflow. You're going to have a bounded range, and you cut off at the edge of the range instead of overflowing. And so there's a lot of very valid uses for it. Here's another interesting little small thing related to numerics complex. Currently at the top there, this is the ugly, nasty stuff you have to do if you want to use structured bindings with complex. Anytime you see a reinterpret cast in your code, you would be, only in certain places should those be allowed. But basically, after this new facility, you can write exactly what you would have expected to write in the first place. Bit sets. In C++20, there were a bunch of standalone functions added to the library. And those are the things that are on the left-hand side. Unfortunately, the container that we have, bitset, didn't get those functions, and you can't use those functions directly on the bitset. These functions, by the way, are made to be hyper efficient, right? Like they're basically reflecting what machines already know how to do, and so they're going to compile to extremely fast assembly. So this proposal is basically bringing these same capabilities to the bitset with one extra twist. You'll see that size t overload there, which then allows you to identify a point within the bitset instead of the entire bitset. Okay, and so there's a whole series of these: rotate left, rotate right, and so forth. And so one of the examples in the paper here is actually being able to go through and, reference the locations where, the value is 0 in the bit set. Okay. How much time we got? Got an hour? No. Okay. So linear algebra. Yeah. This is a big topic, and the good news is there isn't any way. I mean, you need an hour and a half presentation, and you need it from somebody that's not me, because I'm an engineer, but I'm not an expert in the linear algebra field. So there's a number of things that are going in. Sub-MD span, which is something that was supposed to be in C++23 but didn't make it. It was taken out just to make MD span go in. That is back, and it's in the working paper now. And then there's this BLAST-based linear algebra. So here's the long list of kind of stuff it can do. Element-wise vectors, normalization, vector matrix multiplication, all the kinds of things you would want to be able to do. This really comes from basically putting a layer over BLAS. And if you know anything about this area, BLAS has got a long history in Fortran and other languages. There are C implementations of BLAS as well. And so this is basically putting a C++ layer on it, so you don't have to, jump out to that. So here's an example. All of it is coded in terms of MD span. So, you've got your vectors of doubles at the top here. You wrap them up in an MD span, and then you can call it. You'll notice in this particular case, we've got a parallel execution that's going to run across this. So they're parallel versions of the algorithms, which is the other huge part of this library. So everything is written as a free function algorithm like this matrix vector product here. And there's dozens of them. This is a huge paper. There's a lot of stuff there. And basically it's to reflect those BLAS 1 to 3 algorithms into C++ in a first class way. So here's kind of what the definition of that matrix vector product looks like. There's 2 other overloads, so I've only given you like the first one. And you'll see the way this is defined is very patternistic. So you'll see this in matrix, in vector, out vector. And so the output variables you'll notice are also just MD spans. So everything is pass by value here, which is an interesting thing. Even the outputs are pass by value. So that's what's going on here. And again, it's a big facility. If you're into numerics and mathematics, I'm sure you'll look it up. Containers. What are we doing there? So one that isn't quite done yet, I'll call it almost there. It ran into a little bit of issue in Japan. But it's like boost static vector, but basically the idea is this is a drop-in replacement for vector where the storage is in place, and hence the name in place vector. So it's fixed size at compile time, but it's dynamic in its behavior. So you can do pushback to it. So what happens when you push back beyond the end of the size? Well, turns out you get a bad alloc error. You get an exception. So that's the set of decision making. One interesting thing that's been semi-controversial is there is no allocator support for this collection like there is in every other collection in the standard, which frankly simplifies things a lot, but for certain groups makes them really mad because they want to be able to inject their own thing so that, depending on what you're putting in this thing, right, you might want to chain that allocation to the subtypes that are actually stored in the static vector itself. There's a number of other things going on. This is still also an LEWG. So this one is trying to make a nicer interface essentially for map and unordered map. So instead of having to do the various comparisons that you have to do today, you're going to be able to say get, and you're going to be able to chain because you're going to get an optional. So you're going to be able to use like monadic functions and so forth This or construct is a proposed part of this library, which would be added to optional. And so there's a bunch of code here. I'm not going to go through it because we're running short on time. But needless to say, these are, again, small facilities that clean up and make easier to use existing facilities in the standard library. There's a whole bunch of other things, okay? I didn't even bother to blow these into slides because I knew I wouldn't have time. You know, some of these, to me, like the weak pointer as a key in an unordered associative container, it's just not a use case for me. But maybe it is for somebody. Somebody went through the time to write a paper. Maybe somebody wants to do that. 2363 is much more important, but that also has been like a series of papers. There's been changes in earlier versions of C++, you know, that basically do this heterogeneous capability. So this is, I have a string as the key in the map, but I use a string view and to look up the key. I don't want to have to do a conversion. I can compare those two things directly. So that's what these do. And it was just incremental of which methods were overloaded to be able to do this. And this puts the end of it. So all of them will do it, and you're done. Okay. Okay, so we're now at decision point. So I think, who cares about, I'm going to skip SIMD in particular because I already gave a talk about this last year. And this is in progress, and you can go see that talk, and you can go look at these slides, and you can get pointers to what's going on with SIMD. It might not actually get into 26. We'll see. There's been a bit of controversy, to say the least. So ranges, this is a big new facility that's continuing to be built incrementally. So far of this list, and by the way, if you look at the plan paper, it has about 20 or 30 things that they want to have in 26. They're not going to get it all. I can tell you that already, because if it isn't here by now, it's probably not going to make it. Somebody's, you know, paper is going to end in tears at the end of the cycle because they didn't get it in soon enough. And I mean, that's literally the way it works. So we were actually talking about slice earlier. That's one of the ones that's here. There's a bunch of additions to the take and drop family. There's this up to, there's also some additional capabilities. So I'll show you concat. This is the one that's already in. This is really nice, right? You can just concat a series of collections together or views together. They don't have to be collections. In this case, we have a single view here, and they just all look like they're all together combined. You didn't move any data to do that. You're just iterating over that seamlessly. All right. So let's talk about concurrency briefly. Senders, receivers. P2300. Basically, this thing is in the wording review. There's an ongoing set of work on GitHub on this proposal. It's very complicated. It's very long. Library Working Group has been working on this now for better part of a year. One pass has been made through this paper. We're actually kind of hopeful that we're going to get done with this pretty soon. Maybe in the middle of this year, we'll get done with the initial wording review. Meanwhile, there's design follow-on, right? So there's more changes that people want to make to this facility. The keynote tomorrow is going to be about this, so no sense in spending time on it here in depth. There's a couple of other things. Read, copy, update, RCU. If you're interested in advanced synchronization protocols, you know, for certain cases, again, these cases are starting to get more corner casey now, I think. Not everybody's going to have these, but if you have this, this is a really important facility. Like Folly, Google, everybody that does big stuff has this. They also have this one, hazard pointers. So these are a different way of doing reclamation in a multi-threaded context, in a concurrent context. All right. So I said I'm just going to skip that. Let's do some utilities. You'll recognize our friend Elias here. So this is a nice little thing. Again, small change to the standard library. If I have a stream, an output stream, or any kind of stream, I can get the native handle to it. So if I needed to call a C function associated with this particular file stream, I can now do that seamlessly. If you go look at the paper, you'll see it's a lot more cumbersome to do this and use streams at all. Basically, you'll abandon streams and use C code instead. This one, member visit on variant. So who uses overload? Yeah, everybody, right? So this overload idea here, it's fine, right? You know, the only sort of weird thing about it is the syntax over here. You got to put the value of the variant on the end here, right? And so what this does, it actually allows you to, it basically makes the visit a member function so you can get rid of the value. So it's just basically syntactic sugar.
But only a single variant.
What's that?
It's not visiting multiple variants.
No, this is one variant, yeah. Yeah. So debugging support. And Brett just left just in time. So this is another facility that's around in various frameworks in various places in various libraries. So basically you want to be able to say, hey, if I'm in the debugger, stop here, right? Otherwise, just continue as normal, that kind of thing. So that's basically what this facility does. This is one of those things that's really sort of quasi, you know, the specification for it is very quasi because it's just, you know, on the boundary of what C++ can actually say about things. But anyway, there's basically 3 free functions in this thing. You know, breakpoint if debugging is debugger present. And so you can put this stuff in your code, and if you're actually doing debugging, it will be useful.
Can you call a debugger on yourself?
Not that I'm aware. I mean, obviously this again, it's at the boundary of the, you know, the language and so forth.
We have our own debug library, and that's probably the most useful part of it.
Oh, okay. Well, I don't know. That's defined in the standard library at that point. So, you know, they may give you extensions that, you know, aren't in the standard. So are we down to 5 minutes? Yeah. Okay. So Constexpr, all the things. This has been a wave for, you know, 3 cycles now. So these are 2 papers. I'll give you the pointers to them. A lot of the C math utilities are already Constexpr, but now some of the ones with complex and so forth are now also Constexpr going forward. And then the stable sort is another facility that you can use in Constexpr time.
Jeff?
Yes?
Does that include also stable partition and in place merge?
I don't believe it does. It's just stable sort. We can find out because we're actually at the end of the presentation. So. Oh, of course it's in PDF, right? So I don't think so. My recollection of it, Ben, is that it was just the one method. Actually, probably if I go to the wording. Oh, no, wait. Did I go to the wrong one? Of course I did. Or did I link them wrong? Oh, Lord. And I skipped over that. So 2562. Yeah. So where's the wording? Here we go. So we got stable sort, all stable sort.
Stable partition.
Yeah.
Yeah, stable partition.
Oh, you got it. Yeah. Yep. It's been about, I think, 7-8 months since we looked at this. So my brain cannot remember that long. All right. Any more questions? Oh, we got one in the back.
Yeah, what about multidimensional subscripts?
What about multidimensional?
Like, are they included in 26?
They were included in 23.
Oh, I missed it. Okay.
Yep. So that's already a done deal. MD-span uses those. So, yeah. All right. Anybody else? Yes.
Okay, so only tangentially related to SIMD and kind of my ignorance, does operator new guarantee alignment now? And if not, how does vector of SIMD or anything like that work?
Yeah.
Doesn't it always guarantee alignment if you call it a type? Like if you a new T, it has to be aligned to a T.
Okay, maybe that's, as I said, my ignorance. I don't know if they changed something in later version of the standard. Normally it just calls malloc, and malloc gives you whatever it gives you, which is 16.
So new has a like it's not a new addition, but new has a aligned overload now, and like the standard library implements it.
Okay. So
And for I think like if it's not like normally aligned, compiler calls that one.
Okay.
It is like an over alignment. So if you kind of like an integer, like I'm not.
Well, the SIMDs are basically structs
Yeah,
of int
should be
which have over alignment.
Should be fine. It's gonna give you the correct alignment.
Okay. And when was that added?
Jeff should.
I don't know.
11.
I don't remember.
14, 17.
No, definitely not 14.
10, 17. Yes.
Okay.
So, I mean, I've given you a preview of some of the features, by the way. So there's a whole other pack of things that are in process, some of which will make the finish line, some of which won't. But we'll see. All right, with that, thank you.